Valerie has written up a simple problem for me to solve. So we're going to solve it together, and we're going to talk about, in this lesson, definitions for transfer functions. So here's our simple circuit, and all we have to do is find the impedance transfer function and put it in standard form. Okay, let's do that. So you may see that these L, R, and C variables have values. And I suggest when you do these kind of problems with values to first put them in, just use the variable, solve that first, and at the end input the values. Then you're much more likely to catch your mistakes if you have any. So let's start with this. We will write the transfer function. We'll call it Z of S, because we're looking at impedance, which is voltage over current. And we can just look at these values, and we have these two in series. So we'll say R plus LS is in the numerator times 1 over CS, and then we add the two together. So R plus LS plus 1 over CS. Okay, and there we have it, we're done. What's that, Valerie? Oh, it's not in standard form yet? Oh, okay. Okay, so I guess this technically isn't a form that is proper because we have these S's at the bottom. So we have to manipulate this equation and put it into standard form. So we'll multiply by CS on each side, and well, that'll reduce, so this cancels with that, R plus LS. Multiply this through, we get, I'm going to move this to the front, LCS squared plus RCS plus 1. Okay, there we have it. Now we are done, right? No? Valerie says this is still not in standard form. This is what we call polynomial form. So in polynomial form, the numerator and the denominator are in a form where each one is a polynomial of S. So we have S squared, S, and a constant. Actually, we should flip this around technically. Let's do that. LS plus R. So then we have our nice polynomial form, but this is actually not yet standard form. So to get to standard form, we need to make the highest order of the top and bottom, we need them to be unity, to be 1. So this is our highest order, so let's first get rid of this. To get rid of this, we have to divide both sides by L over C. So let's do that. Start with the bottom, so we'll get S squared, plus divide this by L over C, so we'll just get R over L, S, and then 1 over LC. Okay, then we'll do this one. We're dividing by LC, so we get 1 over CS plus R over LC. Okay, so this is almost standard form. Oops, this S is multiplied. But we need to get rid of this as well. This numerator, the highest order term, has to be 1. So we can take this 1 over C out and move it to a multiple of the entire fraction. So we'll take out that, and then we have 1 over C, S plus R over L, S squared plus R over L, S plus 1 over LC. So this would actually be our standard form. Okay. And there's one more form that will be very useful as we go forward when we're looking at poles and zeros, and that's factored form. So we're going to go ahead and put these values into here real quick. Move to over here on the board. So if we insert these values, we will get 2 multiplied by S plus 3 divided by 1 is 3, and S squared plus 3 again, S, plus 1 over LC is going to be just 2. I'm missing a squared. So So this would be our numerical answer for this in standard form. In the future, we will also be going into factored form, which if we rewrite it down here, we would just factor everything so that we have a multiplication of s plus or minus some value here. So in this case, we can factor this into 2 plus 1. So this would be factored form. For clarity, Valerie wanted to make sure that you completely understood and that I didn't mess it up. So she wrote out the definitions for each of these forms. The polynomial form is where the numerator and denominator are expanded polynomials of s. So as an example, we could write a s to the n plus b s n minus 1 plus all the terms until we get to our constant value. And in the denominator, we would have the same form. S beta s m minus 1 until our constant term. Okay, so that would be the general form for polynomial form. And then standard form. The coefficient of the highest power term in the numerator and the denominator is unity, which is 1. So we can also represent that as you can have a factor in the front. You could actually have a factor here. It wouldn't matter. And then the important part is that the Sn and Sm, so if this is n power and this is m power, then this coefficient is 1. Then we can just simplify or continue in this fashion to the constant term. So same here, it's gamma Sm minus 1 until we get to the last term, constant. So this is the general form for standard form. You can write it this way. And then the last one, factored form, is where the numerator and denominator are factored. I guess it would be in terms of s, such that the zeros and poles are easily determined. This is for our future section where we're looking at zeros and poles. The general form can be written like this. The a may have a factor in the front again, and then s plus, we'll have 0, so we'll call it z, multiplied until we get to the last one. And then same here, this would be s plus p1 multiplied by all the other ones. Okay, so here's the general form. I hope that's clear enough, and Valerie's happy with this explanation.